Hello and welcome to Color Multimedia Enterprises. My name is Luke, also known as Tianere, and I am going to introduce you to Haxe, programming language and cross-platform toolkit that allows you to create pretty much anything from one code base and one programming language. This does not target platforms, it targets languages. What does that mean? What it does is you program in Haxe, and then the Haxe compiler takes that code, does what it needs to do to check whether you've typed everything correctly, and then it will generate source code. It will then use whatever compiler is available to then build that source code into an executable file that you can then use and deploy on whichever platform that is necessary for your needs. And that is what Haxe does. It is essentially removing the barrier to have to configure compilers to do what you need it to do in order to build applications. So as you can see here, Haxe is an open source toolkit based on a modern, high-level, strictly typed programming language, a cross-compiler, a complete cross-platform standard library, and ways to access each platform's native capabilities. So we will be learning from day one exactly how Haxe works on each individual platform. So as you scroll down, it says that it pretty much shows you which targets you can target. So you've got iOS, Android, HTML5. Nico is a Haxe Foundation thing that allows you to create web servers, and it's also its own virtual machine as well. Node.js, Flash, C++, Python, C#, PHP, and Java. There's a little bit of a history with Haxe. So back in 2004, when Adobe sort of announced its retirement of the Flash platform, it basically decided that Flash wasn't getting very far. I believe that was around about the time when ActionScript 3 came along, and then Adobe, lots of people were still using Flash at the time, obviously, but there was also HTML5 that was announced a little bit later on down the road, and Haxe was Nathan Knass, the founder of the Haxe Foundation, who turned around and said, you know what, we're going to create a language and a compiler that allows us to generate ActionScript 3 code and also produce SWF bytecode. So that's what happened back in 2004. And ever since then, Haxe has now supported all of these different languages, as you can see on the screen right here. So, in order to develop for Haxe, you first need to download the compiler and the toolkit. So you click on download here, and then you download for any one of your platforms. There's the Windows installer for Windows. Obviously, I'm using Windows here. There's also OS X and Linux as well. You can also get Haxe 3.2 from Aptitude, I believe, on Linux, via the use of the don't want to download it, via the use of sudo apt-get. I do not believe that's up to date. I'm not 100% sure, but that's what I did, and as far as I'm concerned, it works. Otherwise, you can download it manually from there, of course, for your 32-bit or 64-bit system. Alright, so once you have installed that, if it does not set up in your path, otherwise, what you would need to do is right click, go to computer, well, I'm just going to go to control panel. You will need to set up your environment. So what you will need to do is you will need to go to System and Security, System. As you can see, I'm using Windows 8.1. If you're on Windows 7, it should be around about the same thing. You go to this. On Windows 7 and Windows Vista, you right-click you go to Start, then you right-click Computer, and then you go down to, if I can remember correctly, it was System Information, I believe, or Computer Information, I can't remember. But if you're using Windows 7 or Vista, that is where you would go to bring up this display or something very, very similar. Then you click on Advanced System Settings. I'm not 100% sure what it is on Windows XP. I have not used it in so long. It is that long ago. Then what you do is click on Environment Variables under Advanced. Then you scroll down on System Variables to Path. As you can see, it's got path here. You go to Edit, and then you put in the path to the Haxe toolkit. Now, the Haxe has already done its job correctly, so it's installed this Haxe path variable here, and then it inserts that Haxe path variable into here somewhere. So it's somewhere in there. So it's already set up for me, so I don't need to do anything. But if for some reason it doesn't do that, that's what you would need to do. You would need to add your path. Alternatively, you can open command prompt using administrator mode, and you can type in set, and you will be able to set a path from here as well. So as you can see, this is path, this is the path variable, and you would need to put in your Haxe path variable there just by simply typing in set path equal to path, like that, to basically say, okay, this is, we want to take what the path was previously, and then you add in path to the Haxe toolkit and the library, which would be something like that. Right, I'm not going to do it because it's already set up for me. Okay, so once you've got that far, and you can do something like Haxe Lib, and if you press enter, if all of that works, then that is fine. Now, if you have ever installed Stencil or any other application that uses or requires Haxe, and it silently installs Haxe in the background, then it is most likely already set up an environment for you to work with. However, if that is the case, it is likely that the Haxe path is not correctly set up to actually direct you to the folder where it is on the system. So when you install it, you've got Haxe Toolkit, Haxe, and then you've got Lib here, right, where all of your libraries are, where you've installed everything using Haxe. If you have installed Stencil, then it is probably the Haxe setup path has probably been placed somewhere else, right? So you're going to need to set that up manually if you have that. So what you would need to do is type in Haxe Lib setup, right? If you scroll down through here, we've got this under miscellaneous setup, set the Haxe Lib repository path. That is where all of your libraries are going to be placed. So if I were to type that, it is going to show me the path. Hit enter for default, which is going to be the Haxe Toolkit /Haxe/path. All you need to do is just press enter, and that is where it is set. If you ever want to use Stencil again, then all you would need to do is type in Haxe Lib setup, followed by the path at where Stencil takes a look in order to build its applications and whichever other application uses it. I disagree with using Stencil for that reason, by the way. If you ever want to use Stencil and Haxe side by side, try to set up Stencil so that it's actually built and put into the Haxe Lib path repository, so that Stencil builds from that repository instead of its own repository, because it causes a lot of problems in the long run, especially with Stencil itself. I'm not sure if there are ways in which you can do that. It might be possible. I'm not 100% sure. I'm not going to go into too much detail about Stencil. This is about Haxe programming. But if you use Stencil, that's probably the reason why your Haxe system will probably not work. So just make sure that your Haxe Lib setup is correct and installed. Now, before you can actually start using Haxe, you will need to install a few things before you can actually get started. You will need to install Haxe CPP, which is the compiler, or not compiler, it is the library that is used to generate C++ source code. If you do not have that installed, it is not going to generate Haxe source, C++ source code whenever you build for Haxe Lib for the C++ target. Okay, so that's what you will need to do before you get started. Since I've got all of that set up, I am going to just simply get started. Now, this is a tutorial series about understanding exactly everything that is going on in the Haxe programming world, and I'm also going to give you pretty much explanations about everything, absolutely everything, including the hardware and how all that works, because believe it or not, when you go to college or university, a lot of the times, well, maybe not university as such, but when you go to college, a lot of the times you just get taught how to program. Sometimes they don't even teach you how these programs interact with the hardware. Sometimes they don't even teach you that. And that's especially true when you're at school, when the teachers ignorantly believe that you're not capable of understanding exactly how computer components work. Well, let's face it, if you're not going to teach people, your students, exactly how these computer components work, then they're not going to be able to understand exactly how a computer programming language is going to work. You know, it's the whole point of teaching, right? So I'm going to teach you exactly how the hardware works, and I'm going to teach you exactly how the Haxe programming language works, because it is vital to know. If you do not know what the hardware does, then there's no point in programming as far as I'm concerned. Absolutely none whatsoever. So, that is what I'm going to do. I am going to be teaching you pretty much everything under the hood and everything in between, and obviously the Haxe programming language. So, first of all, you probably want to create a folder somewhere on your hard drive so that you can create your Haxe programming language and stuff like that. So, in here, I am going to create a few folders. I'm going to create a folder called SRC. So let's say that this folder is basically for your project, your Haxe project. You're starting out fresh. You don't know what programming is. You don't know what the hardware does. You just know that computers work magically. Well, let me tell you that computers are not magic. They just do the things they do because that's the way science works, right? But I'll teach you that as we go along. I'm going to create another folder, and that is going to be bin. And that is it for the time being. For the folders at least. And then I'm going to create another file, which is going to be run.bat. In this run.bat, I am going to edit it. And I am going to say @echo off. if you do not type in the @ symbol, right, when you execute this batch file, which is basically going to run command prompt, which is this thing here, and execute it, if you do not do that, it is going to simply not display anything. It is, if you do not put this @ symbol here, it's going to display echo off, which is not what you want. By typing in @echo off, it means that it is going to silently do what you tell it to do. And then what I want to do is say Haxe, which is going to call the executable within the path that we set up earlier, right? So what that path is basically doing is it's going to have a collection of folders. Whenever we execute a command from the command prompt, like Haxe Lib, for example, like that, it is searching that path, every single folder, for an executable with that name. Once it's found it, it is going to execute it via command, and then it's going to return a result. And this is the result, Haxe Library Manager, right? That's what every single program does on the command line. It searches those paths for an executable and then it executes it. That's what we're doing here. We are going to find a program called Haxe, and we are going to execute it, but with some arguments, right? So anytime you execute something, you will be able to pass in arguments telling this executable to do something, right? So what I'm going to do is I'm going to tell it to find a folder, and I want it to find this src folder, which is here. Now the reason that I put this batch file in this directory is because when I execute it, it is going to be executed from this directory, which is g:/tutorials, right? That is the working directory. A working directory is basically a directory that this command prompt works from. This command prompt is working directory is under Windows/System32. If any program that exists within System32, I can simply run without, it will be able to find it without even looking at the path, right? Notepad is in System32, so I can just type that and it'll open. So that's the default behavior. Okay, so Haxe-CP, that is basically telling the Haxe executable to find the folder src, and that is where all of our source code is going to be. I also want to tell Haxe to find a class called main. That is going to be the main entry point. The -main basically tells the Haxe compiler that this is going to be where we are going to execute from. Okay? When we first start executing things. When we do -cpp, which is a bit different from -cp, so don't get the stuff confused. -cp is locating all of our source files and code. -cpp is telling Haxe to use this target. I want to be able to compile to C++. I want you to target C++. I want you to generate this source code, and I want you to put this generated source code in the bin folder, which is this one here, right? Now I'm actually going to get rid of the echo off so that we can actually see the results. So I'm going to Control S in order to save that file. And if I were to run it now, it is going to come up with an error because it cannot find main. That's because we haven't actually put in a file in here called main. So what I'm going to do, so I'm going to type in a file. I'm going to call it main.hx because that's what we provided it inside of our batch file. I'm going to drag it in here and we're going to open it. Now I am using Notepad++. As you can see, you can use whatever editor you want. You don't have to use it. You can use Sublime, you can use Flash Develop, it does not matter. But I prefer to use Notepad++ because it does not complain whenever I type things that it cannot find, like Flash Develop does from time to time when it can't find certain libraries for whatever reason. So I've got it set up. It's got Haxe syntax highlighting, so I can just delve right in and just tell you what everything does. Alright, so in order to get started, what we need to do first of all is type in package. The reason we need this package is because package basically tells the Haxe compiler this is the root package of this. This is the root folder, right? src. This is the root package. Folders and packages are related in that each package is defined as a folder. So if I were to, for example, create another folder in here and call it core, for example, right? And then I type in, I put in another folder, file in here, and I call it, let's say, app.hx, right? I type in app.hx, I open that. I don't just type in package like that, because it will come up with an error if we were to attempt to use this. I'll show you. So let's set up this, and I want to use app. So I will type in import app like this. In fact, normally we don't need to because it's within the same package that we're using. Well, as you would think. So I'm going to type in class main because that's the name of the class that we want to use. And now we want to set up our main entry point. The way we do that is by doing static function main, and it has to be exactly main like this. The reason why is because the Haxe compiler is going to try and find a static main entry point. The reason we use static is because static basically stands for being sort of global. You need to try to avoid using static as much as possible because anyone could use this function at any point during your program. Now, when I say anyone, I basically mean anything in your application can use main. It could arbitrarily, you could arbitrarily just type in main like that, and it'll actually execute this function here. If you were to do that, that would cause problems along the lines, and you probably don't want to do that. But for the purposes of this tutorial, we need a static main entry function. The function is something that can be called. It is something that is stored in memory as at somewhere in memory. We don't know where. That's what the compiler does. It stores things in the memory, it does things in the memory, and it allocates things in the memory. We don't know where that is because that's what the Haxe compiler is designed to do for us, ourselves. And of course, a class is basically a collection of members such as functions, variables, and a variety of other things which we will go into a little later. So in order to get this started, what I'm going to do is I'm going to import a thing called CPP.lib. Alright, CPP is a package, lib is a class. Every class in Haxe has to start with a capital letter. If it doesn't, it will not run. I want to trace a value to the command line. So let's say hello. I'm not going to type in hello world because that's overused. I'm going to save that eventually when it works. And then what I'm going to do is I'm going to go back into my folder. I'm going to go back into here. I am going to open command prompt, and instead of doing it the way I did by double clicking on run.bat, instead what I'm going to do is I am just going to say run, and it is going to execute and compile what we wrote. It is generating all the source code, and then it's going to tell HXCPP is going to tell MSVC, which is the compiler that it found, to then build an application using that generated source code. But it partially generates it. MSVC then tells another program called link.exe, as you can see, to link up every library that is needed in order to eventually generate the running, working executable. So now let's take a look into here. We now have a variety of different files. We've got a src file, which is a collection of C++ source code, which is what we were using. We've got a variety of other things here. And if I were to double click on this main.exe, it is going to open, and then it's just going to close straight away. Let's fix that. So what I'm going to do is I am going to say, I'm going to import cpp.file, I believe it is. No, it's not. It's cpp.io. Let's take a look. So we need to take a look at the API documentation. This is a very good place to find out what things do, and it's actually under sys, I believe. Yes, it is. Is it in here? No, it is not. I was doing this the other day and I cannot remember. So we can do lib.print and a variety of other things. We can also read characters. I can't remember where I found it. Where was it? Bear with me. Okay, I'm just going to type in read car. Why does the search only search for classes and not functions as well? That's annoying. Okay, let's just take a look. Returns bytes. No, I'm not looking for that. Looking for something that allows us to read the command line. Is it under here? I think it might be. Ah, yes, it is. Of course it is. Right. Yeah, it's this get car here. So what I'm going to do, so I'm going to go back into here. I'm going to get rid of that because we no longer need it. I'm going to type in sys dot gets. It was get car, wasn't it? Yeah. Get car. We're going to pass in false. So what false is going to do, it's going to say reads a single input character from the standard input and returns it. Setting echo to true will also display it on the output. We're going to say it to false because we do not want to display the integer value that it would otherwise display, and this will prevent the window from closing on us. Now, so let's rerun that. And once it has finally built, we can then rerun main.exe, and as you can see, it is no longer instantly closing on us. It is printing hello as we expect, and it is no longer closing. So if we want to just close it, we can close it like that. There is an alternative that we can do, and that is to do a while true statement, and that will consistently loop until we close it. That will do pretty much the same thing, it's just a different way of doing it. Some people prefer to do that, and it's probably the better way to do it. So we'll do main.exe, and once again it doesn't close. What's even better is if we were to use a variable. So I'm going to do static var running, which is going to be a bool, meaning it's a boolean value, and a boolean value takes two values, which is true or false. Is it true or is it false? Well, first of all, what I'm going to do is I'm going to say running, and I'm going to equal that to true, and instead of saying while true, I'm going to say while running. Now what I'm going to do is I'm going to say if sys dot, and I believe there's a way of actually getting a value from the standard inputs, I believe, if there is a way. Might be, that might not. Print any value on the standard outputs. Print. How about reading the standard input? Since process standard input from which you can read what user enters, usually a block until the user sends a full input line. Yeah, so that is what we would need to do. So let's take a look at input, and we are going to read a string. So read line or read string. So we'll do read line. So what I'm going to do, so I'm going to go back into our source. We are going to say if. So if we go back to here, we want to get the standard input. So we are going to get the input for our input is equal to sys dot input, like that. Oh no, std in even. Std in. Then what we want to do is we want to say if inputs dot read line is equal to exit, then we want to say running is equal to false. So what we're doing is we're guessing this input, so because that's why it returns. So I clicked on that to check to see what that does. We're going to check to see what we can do with that. We can read lines, and I actually typed that wrong. It's actually like this. I'm going to save that. And if that line is equal to exit, so if we type in exit and then hit enter, it is going to set running to false, which means it is going to close. So let's check to see if that is in fact correct. Can we do that? So let's build it. Everything seems fine. Let's go back into main.exe. We are going to say exit like that, press enter, and it closes. So that all works. So what about this app? Let's check to see how this app works. So if I were to type in a class here like this, and I type in public function new like this, now if I were to try to create this, so let's say we've got static var app, which is an app, and then we say app is equal to new app. So I'm just going to save that, and then let me try that again. And then I'm going to run once again, and now it's saying type is not found, app. The reason why is because each package is on a folder by folder basis. It needs to find the folder that it's in. The folders, by the way, also need to be all lowercase, all of them. Core needs to be lowercase. Any folders that you create in SRC needs to be lowercase. When you type in, because it could not find app because it believed that app is in the folder of SRC, right? The reason it believed that was because it does not contain the package. It doesn't. So I need to correct that by typing in package here, saving it, and then running it. Oh, and then we also need to import it because it, again, does not find it. So we need to actually type in import core.app in order to find that app class. So we need to import it. So now, when we run, it successfully finds out that it can in fact find that app class, and now it can build successfully. Now, obviously, app doesn't do anything, so when we run our executable, it is just going to say hello. When we type an exit, oops, well, it's not going to do anything. That will do something. When we type in that, that's what it will do. So I'm going to leave it there for the time being. Thank you very much for watching. I hope you enjoyed. In the next tutorial, we will be taking a look at variables and how they all work. And we will also go into a bit more detail about how the compiler and the CPU works, and be talking about arithmetic logic units and all sorts of different things. So thank you very much for watching once again. I hope you enjoyed, and I will see you next time.